How is filtered milk made? Inside the factory, there is a glass of milk on the table that looks exactly like the milk your grandparents drank. Yet it can sit unopened in your fridge for 45 days, contains almost twice the protein, and has had nearly all of its sugar quietly stripped away without a single artificial ingredient being added. How can something appear so ordinary while being so radically transformed? And how do you remove bacteria, separate sugars, and concentrate protein from a liquid as delicate as milk, all without changing the taste a single person would notice? The answer is hidden inside enormous stainless steel factories where milk is pushed through membranes finer than anything the human eye could ever see. Filtered milk has quietly become one of the most popular drinks in the modern dairy aisle. You will find it in homes across Britain, the United States, Canada, and much of Europe. Poured over breakfast cereal, stirred into coffee, mixed into protein shakes, and handed to children who need calcium to grow. People love it because it tastes clean and smooth, lasts far longer than traditional milk, and gives them more protein and less sugar in every glass. For anyone watching their diet, building muscle, or simply trying to waste less food, it feels like an upgrade on something humans have been drinking for thousands of years. But have you ever wondered how it is actually made? How does an everyday farm liquid become a high-protein, long-life product that can survive weeks in your fridge? Today, we are going to follow the complete journey, from the udder of a dairy cow all the way to the sealed carton in your hand. It all begins on the farm. Every drop of filtered milk starts as raw milk drawn from dairy cows, and the quality of the final product depends entirely on the quality of that starting liquid. A single modern dairy cow can produce around 28 liters of milk every single day, and a large commercial farm may milk several thousand cows in rotating shifts that never truly stop. The animals are milked by automated systems, often robotic units that clean the udder, attach gently to each teat, and draw the milk away under carefully controlled suction. The moment the milk leaves the cow, it is chilled rapidly to around 4 degrees Celsius, because warm milk is the perfect home for bacteria, and every minute counts. From the farm, refrigerated tankers collect the milk and transport it to the factory, and each tanker can carry as much as 30,000 liters in a single load, sloshing inside polished steel vessels designed to keep the temperature locked down throughout the entire journey. When a tanker arrives at the dairy, the milk is not simply pumped straight inside. Before a single drop is accepted, samples are taken and tested for temperature, fat content, protein levels, antibiotics, and any sign of contamination. If anything is wrong, the entire load can be rejected on the spot. Only once the milk passes these checks is it allowed to flow through thick hoses into towering refrigerated silos, some of which can hold over 150,000 liters at a time. These silos stand like giant metal towers, constantly stirred and chilled, holding a vast reservoir of raw milk waiting for its transformation to begin. But this is only the beginning, because the milk in those silos is still completely raw, and what happens next is where the real engineering starts. The first major stage is separation, and this is where the factory begins to feel like something from science fiction. The cold raw milk is pumped into a machine called a centrifugal separator, a sealed steel drum that spins at an astonishing speed of around 6 to 10,000 revolutions per minute. Inside, the force generated is thousands of times stronger than gravity. Because cream is lighter than the rest of the milk, this spinning flings the heavier skimmed milk outwards while the lighter fat is forced inwards, splitting a single stream of whole milk into 2 separate flows in a matter of seconds. The separator can process tens of thousands of liters every hour, and it does so silently and continuously, with nothing visible from the outside except pipes entering and leaving a humming steel cylinder. By controlling exactly how much cream is added back later, the factory can dial in whole, semi-skimmed or skimmed filtered milk with incredible precision. The real transformation, though, happens next. Now we reach the heart of the entire process, the stage that gives filtered milk its name and its remarkable properties. The separated milk is sent into a vast wall of filtration units, and standing in front of them is genuinely impressive. Picture row upon row of long, horizontal steel tubes, stacked in frames that can reach several meters high and stretch across an entire room, all connected by a maze of gleaming pipes, gauges, and valves. Inside each of these tubes sit ceramic or polymer membranes, riddled with holes so small they are measured in millionths of a millimeter. The milk races through these membranes under high pressure, while microscopic pores trap unwanted particles and let the good components pass through, and thousands of liters surge through the system every single hour. The genius of this stage is that different membranes have different sized holes, and by choosing the right pore size, the factory can decide exactly what to keep and what to remove. The first type, microfiltration, uses membranes with pores around 1/10 of a micron wide, small enough to physically block bacteria and many of the spores that cause milk to spoil. By straining out these microbes mechanically, rather than blasting them with extreme heat, the milk stays fresher for far longer while keeping the fresh, clean taste that aggressive heat treatment can damage. A microfiltration line in a busy dairy can clean over 10,000 liters an hour, removing the vast majority of spoilage bacteria before the milk has even been heated. This solves one problem brilliantly, but it also creates another, because removing bacteria alone is not what gives high-protein filtered milk its signature nutrition. To achieve that, the milk passes through an even finer stage called ultrafiltration. Here, the membranes have pores so tiny that they hold back the large protein molecules while allowing water, lactose sugar, and minerals to slip through. As the milk is pushed across these membranes again and again, the proteins become more and more concentrated on one side, while the watery, sugary portion, known as permeate, drains away on the other. This is the secret behind those cartons that boast almost double the protein and half the sugar. There is no protein powder being tipped in, no chemistry set of additives, simply the milk's own natural proteins being gathered together and its natural sugars being gently filtered out. The amount of lactose that can be removed this way is significant, which is also why many filtered milks are far easier to digest for people who struggle with ordinary milk. It is a purely physical process, and watching thousands of liters flow through that towering membrane wall, you would never guess that the milk is being rebuilt molecule by molecule as it passes through. If you are enjoying this journey inside the factory, take a moment to subscribe, because there are countless everyday products hiding extraordinary engineering just like this, and we take you inside the machines that make them. Once the milk has been filtered and its composition perfected, it is ready for the stage that locks in safety and shelf life. The milk flows into a pasteurizer, a dense network of stainless steel plates packed tightly together inside a frame. Hot liquid runs on one side of each thin plate, and cold milk runs on the other, so heat passes through the metal without the two ever mixing. For standard fresh filtered milk, the liquid is heated to around 72 degrees Celsius and held there for just 15 seconds before being rapidly cooled again, a flash of heat that destroys harmful bacteria in the blink of an eye. The entire heating and cooling cycle happens in a sealed, continuous flow, with the milk racing through the plates so quickly that it spends only moments at high temperature. For longer life products, the milk can be pushed to ultra-high temperatures of around 135 degrees Celsius for just a few seconds, a process so effective that, combined with the earlier filtration, the milk can survive for many weeks. This is where one problem is solved, but the milk is now hot, and a warm product is useless on a shop shelf, so what happens next must reverse everything in seconds. Before or after this heat treatment, depending on the product, the milk usually passes through a homogenizer, and this machine is a quiet powerhouse. Inside, the milk is forced through an incredibly narrow gap under pressure that can reach 200 bar or more, which is well over 1,000 times the pressure of the air around you. This violent squeeze shatters the fat globules in the milk into tiny, uniform droplets, so small that they no longer float to the top. This is why your filtered milk never forms a layer of cream and stays perfectly smooth from the first pour to the last. Without homogenization, every carton would separate, and that single high-pressure jet is what keeps the texture consistent throughout. However, this is still not the stage that finally delivers the milk into your hands. Now, the perfected, filtered, pasteurized, and homogenized milk is finally ready to be packaged, and the filling hall is perhaps the most visually spectacular part of the entire factory. Here, long automated lines stretch into the distance, and cartons or bottles move along conveyors in an endless, blurring stream. On a high-speed line, the machines can fill and seal more than 20,000 containers every hour, which works out at hundreds of cartons passing through every single minute. For carton lines, flat reels of packaging material are fed into the machine, formed into shape, sterilized, filled with the exact volume of milk, and sealed at the top, all within a sealed, sterile chamber that keeps bacteria out at the critical moment. For long-life milk, this filling happens under fully aseptic conditions, meaning the sterile milk meets a sterile container in a sterile environment, which is exactly how it can sit safely on a shelf for months without refrigeration. The precision here is remarkable. Sensors check the fill level of each container, rejecting any that are under or overfilled, and the whole operation is choreographed by automated systems that need barely any human hands. As the sealed containers race onward, they pass beneath coating units that fire ink or laser markings onto each one, printing the date and batch information in a fraction of a second as the packs fly past. Robotic arms and automated grouping machines then gather the finished cartons together, stacking and bundling them into trays and shrink-wrapped multi-packs, before mechanical palletizers build towering, perfectly aligned stacks ready for the warehouse. Watching a packaging hall in full flow, with thousands of identical cartons streaming past under flashing sensors and swinging robotic arms, is to witness industrial precision at its absolute peak. Throughout every one of these stages, quality control runs constantly in the background. Samples are pulled from the line and tested for protein, fat, bacteria, and taste, while automated cleaning systems flush the entire network of pipes and tanks with hot water and detergent between production runs, scrubbing the system clean without a single part being taken apart by hand. This relentless hygiene is what allows a factory to handle hundreds of thousands of liters a day while keeping every carton safe. Once packaged and approved, the finished milk is moved into vast chilled warehouses, where it is held at low temperature before being loaded onto refrigerated lorries. From there, it is distributed to supermarkets and shops, often reaching shelves within a day or two of leaving the production line. A single large dairy can dispatch millions of liters of milk every week, feeding entire cities from one site. The global appetite for this product is enormous and still growing. Filtered and high-protein milks have surged in popularity as more people seek out extra protein, lower sugar, and longer shelf life, and they now sell in huge volumes across supermarkets in Britain, North America, Europe, and beyond. Shoppers reach for it to fuel workouts, to feed growing families, to make their weekly shop last longer, and to enjoy a glass of milk that simply feels lighter and cleaner. What was once a niche idea has become a mainstream staple found in fridges around the world. So the next time you pour a glass, remember the journey it has taken. From a cow producing 28 liters a day, into tankers carrying 30,000 liters at a time, through spinning separators turning at 10,000 revolutions a minute, across towering walls of membranes with holes measured in millionths of a millimeter, through plates of flash heat and jets of pressure over 1,000 times stronger than the air around you, and finally onto filling lines sealing 20,000 cartons an hour. An everyday liquid, quietly rebuilt by some of the most precise engineering on the planet, all so it can look completely ordinary in your hand. Now that you have seen the hidden engineering behind something as simple as a glass of milk, did anything about this process change the way you think about what is in your fridge, and which everyday food or drink would you like us to take inside the factory next?